Good morning, everyone. We will be presenting Chapter 12, which is about improvised explosive characteristic, detection, and analysis. Our group comprised of Cheong Sim Peng, Glenna Tan, Tian Ai Ning, and Yap Jia Le.
Blending is physically mixing fuels and oxidizers. It is more simple and common because less chemical skill required, while cooking is chemically mixing together and form new chemical with explosive properties, hence it is more complicated and more chemical skill required. Ammonium nitrate, fertilizer grade and explosive grade ammonium nitrate are in small pellet form. Fertilizer grade ammonium nitrate has lower porosity while explosive grade has higher porosity. Explosive grade is optimized to absorb 7% diesel utilized in N4 while fertilizer grade is not. If improvised explosive is in pure form, ammonium nitrate is mixed with liquid fuel. If pulverized form, it is blended with solid fuels. Ammonium nitrate is stable explosive and shows good thermal stability, but in smokeless powder, pyrodex and nitromethane are energetic materials causing thermal destabilization due to innate thermal characteristics. Icing, sugar, sulfur, and aluminium have lower melting point than ammonium nitrate causing thermal destabilization. Ammonium nitrate mixed with low percentage of aluminium powder will cause highly sensitive to static discharge. With sources of chlorate will cause formation of ammonium chlorate which can lead to spontaneous ignition. With zinc will cause explosion below the melting point of ammonium nitrate. Primary residue is unreacted traces of ammonium nitrate by using IR and X-ray powder identification. Ion chromatography analyzes cation ammonium and ion nitrate and sugar. Elemental analysis is used for metal fields to detect insoluble residue containing their oxide. Focal residue search as close as possible to blood site with at least 60-meter outer boundary. Fertilizer-grade ammonium nitrate explosive produce more post-blast residue due to less efficient mixing of food into denser fertilizer prior causing excess ammonium nitrate. Explosive utilizing aluminium powder produce higher denotation temperature leading more efficient reaction leads to less post-blast residue produced. Urea nitrate. Urea as fuel react with nitric acid as oxidizer will produce explosive urea nitrate. It is in pure form and require a booster for initiation. It reacts with concentrated sulfuric acid to form explosive nitrourea. It is more stable than ammonium nitrate and highly insensitive to friction impact and electrostatic discharge. It is highly corrosive and readily attack most metal due to the nitric acid loosely bonded with urea molecule. Urea nitrate residue will break into urea and nitric acid due to the presence of moisture. Presence of nitrate ion is one of the post-blast indicators which detected by field tests regarding specific color reaction with p-dimethylaminoacinamide. Urea nitrate molecules are detected by mass spec and HPLC also can use to analyze its residue extraction.
For pyrotechnic batch IEs, the formulations are prepared by blending and limited to deflagration reaction. The most common precursors to produce pyrotechnic formulations are chlorate and perchlorate such as potassium chlorate, sodium chlorate, and potassium perchlorate. Commercially, they are commonly found in fireworks. Either materials mixed with metallic fuels such as aluminium or magnesium powder produce flash powder. Sometimes sulfur is included to increase the sensitivity. Amateur bomb makers usually cut open the fireworks, transfer the powder into a container, ignite, then it will explode violently. Chlorate mixtures are far more sensitive than perchlorate. The composition of chlorate produces 10 times heat energy of perchlorate. The most dangerous mixture is potassium chlorate with sulfur. Analysis for post-blast residue presence as solid included IR, XRPD, and SEM-EDX, while IC and CE for solutions. Next, permanganate formulations are less powerful than other IE mixture. Potassium permanganate mixed with aluminium powder, magnesium powder, icing, sugar, or sulfur to produce low explosive behavior. Permanganates are fairly labile oxidizer. When mixed with aluminium or magnesium powder, potassium permanganate produce mixture that are possible to be set off by human static. The confirmation of presence of permanganate ion is obtained by IC analysis. Next, we will talk about nitrate salts oxidizer. Aside from ammonium nitrate, the most commonly encountered nitrate salts in IE formulations are sodium, potassium, and calcium nitrate. Nitrate salt tends to produce low explosive formulations that do not detonate. The most famous is black powder, which consists of potassium nitrate, charcoal, and sulfur. Nitrate oxidizer is fairly stable and it produces robust mixture. When mixed with highly reactive fuels, it tends to form mixture associated with low explosive. For post-blast residue, Observable unreacted nitrate salts can be analyzed by methods such as IR or XRPD, while aqueous extract are analyzed by IC or CE.
Next, peroxide-based IED. It is based on peroxide bond, and there are basically three major types. The first one is acetone peroxide, next is HMTD, and the third one is other peroxide-based explosives. There are two forms of acetone peroxides, which are the dimer, diacetone diperoxide DADP, and also the trimer, triacetone triperoxide TATP. For DADP, it has a spice-like odor similar to cinnamon, whereas for TATP, it has a white crystalline solid appearance with a fruity odor. TATP is more easily produced, and thus it is the most used peroxide in terrorist attacks. Hence, TATP will be the main focus in this section. For HMTD, which is also known as hexamethylene triperoxide diamine, is a white crystalline powder resembling flour, as you can see in the picture here, with a minor hint of fish-like odor. It is also used by terrorists, but less frequently than TATP. For other peroxide-based explosives, terrorists have started to use it starting the year of 2002 to 2003. For TATP's explosive characteristics, it was initially applied by terrorist groups as improvised initiators. This is due to it resembles about 80% of the strength of TNT, and it also cannot be detected with conventional TSA equipment due to lack of nitrogen. It is also named the name Mother of Satan as to the lives of many bomb makers. Some of the examples of illegal usage of peroxide-based IED include, for TATP, it can be seen in the shoe bomb used by Richard Wright in the year 2001, whereas for HMTD, it is used by the Millennium bomber Ahmed Ressamt in 1999. And for CHPX mixtures, it is used in the London transport system attacks in the year 2005. TATP should always be treated in great care, as its stability varies tremendously based on its purity. Due to TATP has a very high vapor pressure, thus it is recommended that its residue be packaged in heat-sealed nylon bags as soon as possible. And here are some methods for detection and quantification of TATP.
On the crime scene of explosive, it is crucial to perform some field analysis to ensure the safety and to expedite investigations. For example, thermal susceptibility test. The sample size required for this test is below 30 mg or a small drop. This test is performed using a gentle flame on the sample and preferred in a location well away from the main body of sample being tested. Next, narcotics test kit. The chemical inside the test kit may initiate some certain IE materials. For this reason, it's important to pay a great caution when applying the drug test kits that contain strong acids. When performing the drug test kits, small test samples should be removed and perform the test away from any bulk amount of unknown powder. Besides that, small tests also can be used to test for the possible presence of explosive in the field condition. The samples mostly collect in trace quantities and exposed to chemicals which induce color-producing reactions. In the field analysis, instruments also apply to screening the explosive compounds. The two most common are field portable Raman and IR spectrometers. The forensic lab analysis of improvised explosive will discuss based on the procedures conducting in FBI laboratory. First of all, screening all the evidence for safety to ensure no live explosive device or components are present before shipping to a laboratory. Secondly, safety inspection also should be performed at the receiving laboratory. After that, develop the exam plan to determine the sequence of forensic examination that each item of evidence will be subjected. In complex cases, forensic examinations from all affected disciplines will meet and develop an approach to optimize evidence recovery. After an exam plan has been developed, evidence will undergo chemical analysis. Depending on whether bulk quantities of unknown chemicals or trace samples are present, will dictate the techniques utilized. The trace residue collected from field and laboratory will be divided into equal portions and subjected to both aqueous and organic extractions. Then these specimens will be subjected to GC analysis. It's hoped that this video has supplied enough information to aid in recognizing danger of handle the hazards of improvised explosive. That's all. Thanks for watching our presentation.